Hello seniors, sorry I can't be with you today. I would like to give you some help with one of your homework problems. So if you would turn your practice packet to page 42, and this is number 2. We've been studying Newton's laws of motion, and I just want to help you see the relationships that you have in problems that have a normal force and a friction force, and also looking at the components of gravity. So if you would pause this video while you read number 2 about the most massive car ever built. Hopefully you did the pause, because now I'm going to direct your attention to the board. And I just wrote down what information, oops, not quite that high, what information was given to us. I've got our free body diagram there. Looks like we have a 10-degree ramp. And we have this massive car that's going down the ramp. And I also wrote down the information that we know from the problem. We know the net force. And when they give us the net force there, that's the sum of the forces in the x dimension. I have a plus sign up the ramp and a minus sign going down the ramp. So in this case, the net force is a negative 20,000 newtons. So let's see what we know. We know the net force, and then by looking at the components, I know that the net force is the force of friction minus the force of gravity going down the ramp, or the F of G of x. So what I want to do is just write down some relationships between the force of gravity, the normal force, and the force of friction, keeping in mind that we are trying to solve for the mass of the car. So all these forces are related to mass. So let's get after this right over here. I need to go down just a little bit. Okay. So I know that my force of friction, I'm going to rewrite this as the normal force. So I know it's going to be the normal force times the coefficient of friction, and then minus F of G of x. That is my net force. I know the normal force is also equal to the F of G of y. So I'm going to go ahead, instead of normal force, I'm going to put down F of G of y. So now I have the two components of gravity in here. This is important because I'm trying to solve for mass, and I'm going to get my mass using these components of my gravitational force. So if I continue solving, I could say coefficient of friction is equal to, well, F of G of y is the cosine of 10 degrees times the force of gravity, minus F of G of x is the sine of 10 degrees times the force of gravity. I'm closer to solving for mass. So now I'm going to go ahead and I'm going to factor out my force of gravity. And I have the coefficient of friction times the cosine of 10 degrees minus the sine of 10 degrees. The force of gravity is mass times acceleration. So I'm going to put mass times acceleration, and this is mass of the car times the acceleration of the car. And then I continue on. I just carry down my equation. Now I can rewrite this equation to solve for mass. And to rewrite that equation, I would end up with mass being equal to the net force divided by all of this acceleration times this expression. So we've got acceleration due to gravity times coefficient of friction times the cosine of 10 degrees minus the sine of 10 degrees. And if I continue solving this, plugging my numbers into my calculator, I'm going to solve for the mass of the car. Remember, the net force was given to us as 20,000 newtons at the beginning of our problem. Now, just to summarize, remember when you're solving for something like math, you need to look at the relationships between your net force, your force of friction, your normal force. And you can always write in mathematical expressions that incorporate math. I couldn't just solve for mass at the start of this problem. I had to look how all of these forces were related, and then finally I got down to a math expression that had math in it. Hopefully this helps you as you solve your homework problems.